Yeah, so welcome once again, friends, to the AI Club. And this is a machine learning channel where we are discussing tutorials on machine learning, deep learning, NLP, probability, statistics, and whatnot. So today we are discussing probability. This is day 4 of our probability for statistics for data science. We are conducting a course on statistics for data science, and this is fourth lecture, day 4. So far we have covered very basic things about probability. So today we will look little advanced. So what we have covered is variable events. Then today we are going to cover these laws of probability: union, intersection, probability in series, probability in parallel, and Venn diagrams. Okay. So this is today's topic. So you can see. So this we are going to cover today. So I'm going to use this formula. This is which is your probability in union. So what is a union? So union means, as I said, if you have a, set with values 1, 2, 1 comma 2, and another set with values 2 comma 3, the union will be 1, 2, 3. 2 is repeating, but 2 we cannot repeat anything in sets. Okay, so that you are very clear. Now see the Venn diagram in the left with greenish circles. So the entire rectangle which you see, the entire rectangle which you see in which these two circles, overlapping circles are made. So entire rectangle represents the sample space, the entire complete sample space, in which A is the independent event and B is the independent event with some overlap. So now, as you can see, what is the what is the specialty in this? The intersection which you see between these two circles, intersection portion. So like it is what is the specialty in this? Can anybody tell me? If I want to find A union B, what I need to do? If I do simply PA plus PB, like probability, PA means one circle, left circle, PB means right circle, green circle. If I do only PA plus PB, what's wrong in that? Tell me.
You will have this two time.
Yeah. So intersection portion which you see will be repeated by A also and will be repeated by B also, right? So if you want A union B, you have to minus one. There are this intersection repeats 2 times, so you have to minus one, right? So now simple formula: A union B is equal to PA plus PB minus P intersection B. You can see the formula on the right hand side. You can see formula on the right hand side. So now you see on the right hand side corner, right hand side below corner, on the right hand side below corner, like this corner, right hand side below corner. So I have made 2 circles, white circles. So above circles are like top circles are representing 2 mutually exclusive events. A and B are mutually exclusive. So we have discussed that what is mutually exclusive. Nothing is common. So intersection A intersection B will be 0 because events are mutually exclusive. And below that, white circles, if you see A and B, so A and B are overlapping. You can see, right? You can see A and B are overlapping. So they are non-mutually exclusive. So when mutually exclusive events are there, PA intersection B will be simply PA plus PB, right? If events are non-overlapping, the A union B is PA plus PB because A intersection B is 0. Is it understood, Parik bhai?
Yes, sir.
And if they are they are independent events, but non-mutual, they are overlapping events, then it will be PA plus PB minus P intersection B. Got it?
Yes, sir.
Everyone understood these formulas?
Yes, sir.
Yes, sir.
So we have 2 cases here. One is mutually exclusive, where where minus P intersection B will be 0, and there is mutually non-exclusive. So for that, there will be one time P intersection B. So this formula now should be understood. Now we'll take one example.
Sir, in that formula, when we say that,
Yeah, tell me.
yes, sir, in the earlier side,
Yeah, earlier slide. Yeah, tell me.
sir, here, I mean, when we are saying that minus P A intersection B,
Intersection B. Yeah.
so it will be the total of intersection, or I mean, how it will be considered
A
as one?
intersection B is PA into PB.
So let's say, sir, I mean, we have 1, 2, and 2, 3. So at that time, when we are minusing this 2, so the 2 will be
Only 2
removed.
will be minus.
But I
See,
mean,
if you add everything, if you were set with 1, 2, and 2, 3, if you combine everything, it will be
yeah,
1, comma 2, comma 2, comma 3.
yes,
Okay.
correct. Yeah.
So from the set, you will minus 2, which is the A intersection B.
So two
One
time is
element
there.
you have to minus.
Acha, okay, one element we have to minus. I mean, 2 is 2 times, so 1, 2 we need to
Yeah, 2
remove.
times, so that we have to minus.
Okay.
Because a set cannot have repeating values. That is a fundamental property of any set. You read
Understood.
little bit of set theory,
Yeah.
then it is a very basic is that set will have only unique values. So like if we one set A is having 1 comma 2, set B is having 2 comma 3. So A intersection B is 2, right? Because 2 is common. So if you combine them, it will be 1 comma 2 comma 2 comma 3. And
Yeah.
if you then you have to find A intersection A union B means it should be 1, 2, 3, right? So 1, 2 you have to minus from that. Understood?
Yes, sir.
Okay, now we'll do one numerical example. Like if you do one numerical example here, what is the probability? See example 1. What is the probability of selecting a red card or a 6 when a card is randomly selected from a deck of 52 cards? So a card deck is having 52 cards. So you have to find out what is the probability of selecting a red card. A red card or a 6 or number 6. Red card or number 6. Okay. So it is or, right? So or means addition. It will be union. Or means union. Okay. So red card or with number 6. So see, now how many red cards are there in how many red cards are there in slide of 52?
13.
26 are red cards, right? Out of that, out of 52, how many cards are having number 6 on it? 4 cards, one of each color, right? Now number of red cards that are level 6 are at 2. Number of red cards that are also labeled 6 are 2. Understood?
Yes.
It's clear. So even if it is not clear, he is giving the numbers. Let us assume that number of red cards with 6 or 2. You can see if you have a card deck, you can see at home. Number of red cards with having a 6 label on it will be 2. So what is the probability of getting a red card? A red card, which is PA, 26 by 52. 26 by 52, because there are total. What is the probability of getting a red card? Because there are total 26 red cards. So 26 divided by total 52. What is the probability of getting a card with 6 of any color? So that will be card with 6. So 4 by 52, because there are 4 cards with any color. 6, 4 card with having 4 card having 6 on it. Okay, one each color, right? So 4 by 52. What is the probability of getting both red and 6? A card should be red and 6 should be labeled on it. So such cards are 2. So 2 divided by 52. So that is A intersection B. Common between red and 4 is red card with red, a red card with 6. So that is A intersection B, right? So that is 2 by 52. Now you want to find the probability. So it will be A union B is equal to PA plus PB minus PA intersection B. So PA is 26 by 52, PB is 4 by 52, and PA intersection B is 2 by 52. So like if you calculate, it will be 7 by 30. What this is, you understood this problem?
Yes, sir.
Everybody? Sarthak, Jignesh, Karthik,
Yes, sir.
Amit, everybody understood?
Yes,
Problem
sir.
is simple. But see, when you see or means it will be a union. Red card or six. It can be red card or six with any color, and it can be a red card. So, like you have to find union. So, union means PA plus PB minus PA intersection B, right? So, then we go to a next problem. What is the probability of getting 2 or 3 when a die is rolled? One, once I roll it, throw it, it should be 2, and second time I roll it, it should be 3. Okay, so either, nahi, okay, sorry, only one time I am rolling, only one time I am rolling the die. I should get either 2 or 3. Only one time I am rolling the die. I am throwing one time only. So I should get either 2 or 3. That is the question. So 2 or 3. So that will be union. So you have to find union, right? Probability of getting 2 is 1 by 6 because 2 is only 1 and total are 6, 1 by 6. Probability of getting 3, PB, is 1 by 6, right? And P, like in the case, PA and PB are mutually exclusive, which cannot include, because as we cannot get 2 or 3 in the same roll of the die. P and 3 are mutually exclusive. Okay, either we can get 2 or we can get 3. So nothing in common, right? Nothing in common. So either 2 will get once you throw, either you will get 2 or you will get 3. So they are mutually exclusive events. So PA intersection B will be 0. So now you apply formula A, P, A union B, PA plus PB minus A intersection B. So A intersection B is 0. So 1 by plus 1 by 6, 2 by 3 is 1 by 3. You get the answer 1 by 3. Understood? So I included this problem because this has mutually exclusive events. On this problem, what? This problem was overlapping events because there are cards with red and 6, both are there. So there are either overlapping events. So I included that both problems. Now we go to next. So now we have to find out A intersection B, A union, so A intersection B. So intersection is represented by inverted U. You can see that formula A intersection B. So one sample space, right? Entire rectangle is our sample space. Left hand and right is our event A. Left hand and right hand is our event B. So if I say event B, probability of A intersection B, that is the red portion, which is the common portion. Okay. So always it is represented by PA into PB. So you remember, whenever there is a union, PA plus PB means total probability will increase. And whenever there is an intersection, see, PA intersection B is less than PA and it is less than PB also. So PA intersection B is less than PA as well as it is less than PB, right? So intersection will always reduce the overall probability. And union, if you see formula union here, so PA union B is greater than PA and it is greater than PB. Okay, because it is a sum of them. Okay. So individually, if you see PA union B is greater than PA and PA union B is greater than PB because it is the sum of both. But if you see intersection, it will overall probability will reduce because PA intersection B is less than PA as well as it is less than PB. Okay. So the same problem, if I say, what is the probability of getting 2 and 3? 2 and 3. So it will be 1 by 6 into 1 by 6. So here it OR means union, and means intersection. So 1, 2, and 3. If I'm throwing 2 dice this time. 2 dice I'm throwing. So one should have 2 on the top and second should have 3 on the top. So 2 and 3. So 2 and 3 means it will be intersection. So A into B. Okay. So now like we saw already, when A and B are mutually exclusive, independent, mutually exclusive means nothing common. So A intersection B will be 0. So it will be like this. Like you see on the this rectangle, this figure on the right hand corner, right and below corner. If you see on the top white circle, A and B are denoting mutually exclusive events. Okay. So for such events, A intersection B will be 0. So the intersection A intersection B will be 0. Okay. So now let us discuss one more problem. Like a container is having 6 red marbles. Marble means वो आंटी खेलते हैं ना, मतलब 6 red marbles and 4 black marbles. That small we play that we used to play in childhood. So round with the glass, they come glass and marbles. Okay. So 6 red marbles and 4 black marbles. 6 are red, and 4 are black. 2 marbles are drawn without replacing from it. Without replacement means I at random they are placed in a blind container, like a matka means there is a blind container which I cannot see inside, and blindly I take out 1 marble. Okay, I take out 1 marble, and then I take out second marble. That also blindly. Okay, without looking at it. When I take first marble, I don't replace it. So when I take first marble I take, so total marble, before taking first marble, total quantity was 10. When I take first out, so total quantity will become 9 because 1 is already taken out. And from 9, I'm choosing 1 more marble. So 2 marble are wrought without replacing it. What is the probability that both marbles are black? The question is, what is the probability that both marbles are black? That's what is the question. Total number of black marbles is 4. And total number of marbles is 10. Like total is 10, 6 plus 4, and out of that black are 4. So probability of getting 4 is black is how much? 4 by 10. Understood, na? Probability of getting 4, because their black marble are only 4. So probability of getting black, which is PA, is 4 by 10. Now we select from the remaining marbles. From remaining marbles, we are taking. So suppose we have taken out black marble in the first random. So what is how many black marbles are remaining? Only 3. Previously there were 4, 1 we have taken out. Now there are only 3 remaining. So now PBA is 3 by 9. So how much will be total probability? Like this question is little bit different. So A intersection B is equal to PA into PB by A. PB by A means after A is taken out, we are taking out B. So it will be 4 by 10 into 3 by 9. 4 by 30.133. So this will be, see, P by A means after A taken out, we are taking out B. So it is 3 by 9. So now we have to find out like both marbles are black, means A and B are black. So and means you have to find out intersection. So intersection is 4 by 10 into 3 by 9. Understood? Is this problem understood by everybody?
Yes, sir.
Yes.
Then now we are getting some practical applications. You are having one circuit. Just everybody understands simple electric circuit. And in this electric circuit, I'm having 2 resistors means that resistance, you know, that resistor is there, na? A electric component which is called resistor. So I'm having resistor A and resistor B. I put them in series. Series means first diagram. A and after that B. And in parallel, so A in parallel B. So which circuit is more prone to failure? A or B? Series or parallel? Which is more prone to failure?
A.
Pardon?
A,
Series
sir.
will fail. Series will
Series.
fail more frequently, or parallel will fail more frequently.
Series.
Why series? Yes, because either A or B fail means circuit will fail, right? Now here the current goes parallel, right? They are in parallel. A and B are parallel. So for circuit to fail, both A and B should fail. So like you just say When A is in series with B, you have to apply intersection. You have to apply intersection. And when A and B are in parallel, you have to apply union. Understood? Union means overall probability will be more, safer. Because when we make rocket and all, when it goes in the like when we work on a rocket, many important parts are put in parallel. Why they are put in parallel? If one fails, the current will go from other part so that circuit will continue, because once rocket leaves earth, there is no chance for any mechanic to go there and correct the things. So many things they put redundant means they are placed in parallel. Generally they don't use series kind of circuits in rockets because the reliability is very less. If either fails, circuit will go for a toss, rocket will be doomed. Okay, so they use many parts in parallel. So when it is in series, it will be intersection. And when they are in parallel, it will be union. Understood, na? Understood? Is it understood?
Yes,
Sarthak?
sir.
Yes, sir.
If anybody doesn't know, you just like you just now I'm seeing problem. See, now here one circuit is there. Okay. So one circuit probability of working of circuit left hand side. See, you see the circuit one like A. Probability of working is 80%. Another circuit which is in series, the probability of working is 90%. So you have to find out how the reliability of overall circuit. Like what is the probability that full circuit will be okay. Okay, so that is L and R, both should be there, right? L and R. So it is going to be intersection. So 0.8 into 0.9, overall probability gets reduced, you see. Individual probability was zero point 0.8 and zero point 0.9, but when you find out series L and R, overall probability is only 0.72. Overall probability reduces. Over probability of overall circuit operating in series is only 0.72 because 0.8 into 0.9. Okay. Now next question. Next question is, I have two circuits like this. Now I have put in parallel. I put in parallel. Both circuits A and B, like both resistor and both parts A and B, they properly function 95% of the time. 95% of the time means 0.995 probability that they will work. Both the parts are same. Now their circuit is in parallel. So find the reliability of overall circuit, means find the probability that overall circuit, what will be the reliability of overall circuit? Means how much I can rely, 80%, 85%, 90%, 95%. Okay. So now what he has done, little trick he has played. What he has done, see, you have to find T union B. So like one is T means upper circuit, and union you have to find out B. So what he has done, he has taken negation of that. 1 minus T dash. T dash means 1 minus like not operating. Not operating is how much? Both the parts. Probability of not operating. Probability of failure is how much for both the parts?
0.05.
0.05, right? So he has taken T dash and B dash. So T dash means 1 minus, like probability of not operating, it has taken, and from 1 he has deducted it. So PT dash, so 0.5, 1 minus 0.5 square. So overall probability this should be equal to sign. Overall probability of operating this, overall reliability of this circuit will be 0.975. It is increased. See, individual was 0.95, but overall circuit, because they are in parallel, overall probability is 0.9975. 99% I can trust on this part. And if I put one more in parallel, maybe it is reaching, it will reach 0.999999. Okay. So like that, you can make parts more reliable. Okay. So now I want you to do one thing when I share this PPT with you. Yes, somebody has to go, like Jignesh bhai, you have to go on mute. Your sounds are coming from the background. See, I want you to try on the back, like I want you to try it from positive angle, like he has tried from negative side. Yes, first calculated the probability of failure, and then yes, subtracted from 1 minus. That's how he has calculated. I want to try it from you. I will see why he has done like that. I'll tell you why he has done like that. P A union see P T union B will be PT plus PB minus PT intersection B. Now here, if you take PT and PB, you have PT and PB both is 9.95. But you don't have the value of P intersection P, T intersection PT intersection PB. Like T intersection B, that value, the intersection value doesn't have. So directly it is very difficult to calculate. Directly, it is very difficult to calculate probability. That's why he has gone from negative side. He has taken probability of failure is 0.95. So 1 minus intersection will be 0.95, 0.95. So intersection will be 0.9975. Okay. So now this is little bit complicated example. So A and B are connected in series, to which part C is connected in parallel. And there is another part with 0.9 probability, D part, which is connected in series. If you want, you can solve it, because point A and point B. So if they are connected in series, their probability will be intersection. So A 0.75 into 0.8, right? And then you have to see parallel probability. And then after that, you have to find again series probability. See here how they have solved. See here, L1 union L2. L1 means upper circuit. L1 union L2. Why union L2? Because they are in parallel. So you have to find the L1. L1 means A and B both. L2 means C. So you have to find L1 union L2, and with that intersection L3. Why intersection L3? Part D. L3 means part D. So why intersection? Because it is in series. So how they have find out, you see. First, let us see L1 union L2. So L1 union L2 formula is PL1 plus PL2 minus PL1 intersection L2. That's what we know, right? So PL1 is PA intersection B. So A intersection B means 0.75 into 0.8, because they are in series. A and B are in series, so 0.75 into 0.8, 0.6. PL2, L2 means part C. The probability is 0.8. Okay. So now you put in this formula L1 into, so PL1 we know. PL1 is 0.6, PL2 is 0.8, and minus PL1 into PL2. PL1 into PL2. So 0.6 into 0.8. We got overall probability L1 union L2 as 0.92. Now with that you have to find out the union of L3. So it will be simply 0.92 into 0.9. Is it understood or little complicated?
Understood, sir.
Understood.
Everybody understood, Jignesh and Amit bhai?
Yeah.
Huh?
Yes, sir.
So that is how probability is applied in practice. So there is a full MTech in reliability engineering in IIT Bombay. So they teach you to calculate reliability of systems. They teach you to increase the reliability of systems. That is full of probability. That full MTech is full of probability. Okay. You just have a bit more look at home. All the things are we have studied in previous slides. So you can make it out how it is calculated. First, L1 union L2. So L1 union L2 is PL1 plus PL2 plus L1 union intersection L2. So that he has calculated individual, and then PL1 union L2 and then intersection L3. So like that they have done in 2 or 3 parts. He has calculated. Okay. So now next one. See, now I want you should not be worried. These are called Venn diagrams of probability. So you see A intersection B, everybody understand? A union B, you understand? Now A dash union B. A dash means in A dash means 1 minus A. A dash means 1 minus A means it should not include anything of A. So A dash is 1 minus A. That means your sample space is always considered 1, right? Because sample space is all probability of all sample space is 1 only. So that rectangle is 1, and out of you have to minus A. Out of you have to minus A. So that will be A dash. And A dash, A dash, A dash, and then you have to find out what is that A dash, and what is that called? A dash. So what is this? A dash union B. A dash union B. Now, is it clear to you? A dash union B. At the end of this course, like end of these slides, we'll work out how to calculate all this. I want just you to understand. Like this is A dash union B. Is it understood? A dash means nothing of A, 1 minus A, union B. So all the green part is A dash union B. Is it understood?
Yes, sir.
Now you see like second row, first one. That is A union B dash. B dash means everything outside B, everything outside B, everything outside B you have to take B dash. And A means A also you have to consider. So A union B dash will be B dash intersection B dash. So common part. So what is the common part? A intersection B dash. That is the green one. Is it understood?
Yes, sir.
A intersection B dash. So B dash means what is common between B dash and A? So B dash means everything outside B. Okay. And A, what is common? So that shaded area of A is common, right? Now next one is A dash union B. Same, like similar to the first diagram. Now second one is A dash intersection B. You got it. So that is easy to explain. Now another is A union B dash. A union B dash. So is it understood why it is the shaded area like green area? A union B dash. So B dash means everything outside of B. And A union B dash. So it is the shaded area. You got it? Got the reason? Is it
Yes, sir.
understood or not?
Yes, yes.
Yes, sir.
And then A dash union B now. Now reverse. It was A union B dash. Now we are calculating third row, first one, A dash union B. Third row, first one, A dash union B. So now it is easy to explain. Now A dash union B dash now. A dash union B dash. So like it is very easily you can calculate. Means A, that is A intersection B and dash. So first you find A intersection B and minus it just A intersection B and find the reverse of that. And then A dash intersection B dash. So it will be A union B dash. Little bit first time it looks little bit. I was also confused. But try to practice and try to if I cannot, very difficult to explain like this in words. But try to find out why this green area is representing what the relation is telling. Now I am telling A dash intersection B dash. So why it is white area shown? Why it is the green area? So you should be little bit giving a thought to it. Like A dash means everything out of A. B dash means everything out of B, right? So you cannot include anything from A. Intersection, you cannot include anything from B. So what will be the intersection? The outside green area, right? Got it, na?
Yes,
Fourth,
sir.
last one. Third row, last one. A dash intersection B dash means you cannot include A also, you cannot include B also. So what is remaining? The green area outside of both, right? Now here A dash union B dash means you have to find out all the area except the common area. Except the common thing, you have to include everything. So that is what green. So that's why intersection only intersection formula has the portion has been excluded. So you just you have to little bit think over it and then prepare a logic for yourself that why the green area is representing that relationship. And with this, you should be able to find out the relation, how to find it out. If I give you PA and PB, if I give you PA and PB, you should be able to find out these relations, all these relations. All the 6 diagrams, you should be able to write formulas. So we'll do it in the end. Actually, I have kept it as an exercise in the end. So we will anyway do it. We'll write formula for all the 6 Venn diagrams. So they are called Venn diagrams of probability. So for all the 6, I will teach you how to write formulas for them. Right now, just as a first, try to understand, and I can imagine that it is tough for you in the first sight. Even for me, it was tough, and I was confused for many days. And then after doing, seeing, it was clear to me. So in the last, you should do some exercise at home today. I share this PPT with you. Okay. So, and in the last, as I said, we'll write formula for everything. If I give you PA and PB, we have to write the formulas for all the 6 diagrams. Okay. So we'll do it. We'll do it then. We'll do it as an exercise in the end. Now, these are relationship summary. I'm summarizing here. PA plus A dash equal to 1. Yeah, A dash means 1 minus A. Okay. A dash means 1 minus A. So PA plus PA dash equal to 1 because it will represent a complete circle. Mutually exclusive events, A intersection B. A is also separate, B is also separate. Mutually exclusive. Right hand side on the top. A intersection B. A is here and B is here, nothing common. So A intersection B will be 0. Union we know, PA union B equal to PA plus PB minus PA intersection B. Intersection we know, PA intersection B is equal to PA plus PB, but events should be independent and they should be overlapping. So any independent events, we assume that something will be overlapping. So PA intersection B, in case of independent events, it will be PA into PB. But in case of mutually exclusive events, it will be 0. Now into independent events, so PA into PB is equal to PA intersection B. So that's what we have learned. And as I told you, we should be able to write formula for each one of 6 rectangles, diagrams. We should be able to write formulas. So we'll do towards the end of this session. Okay, maybe tomorrow or something. So we should be able to write the formulas. I'll ask you to write and one by one we'll write. So this revision is done. Anybody, any problem in union and intersection? We have solved so many problems. We have solved series parallel, right?
Right, sir.
So now this also same. There is one new thing is teaching Bayes theorem. So right now ignore Bayes theorem because we are having one complete session on Bayes theorem. Rest everything you know, guys, already know. Bayes theorem ignore for now because we have a complete maybe 2 hours session on Bayes theorem. It's very important. So based on this, we have Bayesian statistics, Bayes theorem. So I will. We have some good session on this. So now, like now, see mutually exclusive events. Mutually exclusive events. So A union B will be Px plus P by, we know, because the minus factor will be 0. Non-mutually exclusive event, it will be A union Y, A union X union Y, PA plus PY plus PA intersection Y, right? So once again, I am making you should be familiar with this formula now. Addition rule means union. For non-mutually exclusive, it will be Px plus Py, and for non-mutually overlapping circles, it will be Px plus Py minus Pa intersection Y. Sorry, Px plus Py minus Px intersection Y. So now probability Bayes theorem again you ignore. Bayes theorem you ignore, and like these 2 formulas, like we have solved. See, there are left hand side you see on the left hand side. Independent events you are already aware. px plus px into py. Dependent events is equal to pa intersection y is equal to py into, like if events are dependent means event x is dependent on event y. I have explained you like with the help of that girlfriend example. If girlfriend comes, then only we'll go for pictures to see movie. But if she doesn't come, we'll not go. So going to movie is dependent on my girlfriend arriving on time. So here x will occur only if y occurs. So in such a case, px intersection y px intersection y is equal to py into pxy. So we have done one example on this. You have not noticed properly. So I'll show you that example once again. Here, see here we have done dependent events. How? Why we have put this formula? You see, A intersection B is equal to PA into PB slash A. So now, why B slash A? There are, see the problem. There are 6 red marbles and 4 black marbles. Event B happens only if event A happens, right? I take out 1 marble and then only I take out second marble. So if A happens, then only B happens, right? So B is dependent, A is dependent, B is dependent on A. B is dependent on A, right? If A happens, because I have to find out both of the marbles are black, both 2 events are there, and I have to see both events are black. And I'm not replacing the marble. I'm not replacing marble back. So I take out 1 marble, so total marble may become 9. From 10 they reduce to 9. So event B is dependent on event A. Taking out second marble is dependent on first marble. So that's why this formula has been applied. So already this one numerical we have seen on this particular. Give a little bit thought. Everything you may not understand here. So this formula dependent events like right hand side, the bottom one. Left hand side, the bottom one, dependent events. So this one numerical already we have done. So once you go home, you try to revise these things. Now the laws of probability, cumulative law. There are simple laws of probability. If say S union T, it will be equal to T union S. First formula, cumulative. See, I have 2 circles like set A has 1, 2. Set A has elements only 1 and 2. Set B has element 2 and 3. So if I find union A, union B or B union B, both will be 1, 2, 3, right? If I find A union B or B union A, both will be same, right? Is that understood? Commutative? Is that understood?
Yes, sir.
Amit bhai,
Yes, sir.
Yes, sir.
Yes, sir.
Sarthak, Jignesh, Karthik,
Yes,
Yes, sir. Yes.
understood? Now see
Yes.
the second formula on side, right hand side at the top it is written associative. S union in the bracket T union U. Three sets are there, S, T and U. Okay, or 3 probabilities are there, P, S, P, T and P, U. So T and U right now in the bracket on the left side. So right hand side, what I have done? I have combined S and T and taken U out. So it is well, both will yield me the same result. Is it understood? Associative. I can change the position of bracket, but still the result will be same. Now distributive. Second row first formula. S intersection in bracket T union U. So if I have to say distributive, it will be S intersection T. That intersection will now go inside of the bracket. So S intersection T union S intersection U. Is this understood?
Yes, sir.
If there is an intersection and there is a bracket, so that intersection will go inside as a bracket. Okay, so this is one called distributive law, and this is with union. So distributive with intersection, and the second row second formula S union bracket T intersection U. So that union also going inside S union T intersection S union U. Understood? Both, all the four formulas understood? So
Yes.
these are
Yes, sir.
the, like S is a probability, T is a probability, and U is the probability. It's just like your set things here. Okay, so it is if you remember your algebraic law, no? A into B plus C. So what will be if you open it? A into B plus C. A is outside into B plus C inside the bracket. How it will be open? A into B plus B into C, right? That's how you will open it, right? Simple. A, I'm giving once again, A into bracket B plus C. How you will open it? A into B plus B into C, right? So same thing is here. Same property is being applicable here. So it is distributive law or distributive law of probability. Okay. So that's where some numerical can be there on this. So I think you are already available, already available with these non-negativity. Probability can never be negative. Minimum value is 0, maximum value is 1. It cannot be less than 0, it cannot be more than 1. And it can be not less than 0 means it can never be negative. Now, if events are mutually exclusive, PA union B is equal to PA plus B, we have seen many times. Okay. Now, if events are disjoint event means mutually exclusive events, nothing common. So A union A2, union A3, A1 union A2, union A3, all are disjoint event. Disjoint means there is nothing common between A1, A2, A2, A3, and so on. So it will be PA1 plus PA2, like that you can do it. Normalization. All the sample space if I take, the probability, if all the possible probability I take, the sum will be 1. How? See, I'm having a dias, simple dias, pasa, simple dias. So numbers 1 to 6 are there, or each face one number is there. So number vary from 1 to 6. So one face is 1, 2, 3, 4, 5, 6. So my sample space is 1, 2, 3, 4, 5, 6. That is my total sample space. Now, if I see probability of getting any one digit will be 1 by 6 plus 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 1 by 6. So 1 by 6 I have to add up 6 times. If I add them 6 times, the probability will be 1. So that's what is your normalization. Many times we have discussed this. Now this also, like if A belongs to B, does anybody understand this horizontal U? What does it belong to? What does it say? I'll check it and later I'll let you know. But let us see. For now, let us see B. Formula B, A union B. We are familiar.
Is it subset?
Subset? Maybe subset. Yeah. Yeah. Maybe if A is subset of B, then PA will be, yeah. Then it makes sense. Yeah. If A is subset of B, then PA will be less than or equal to PB. So subset means if PB is having element 1, 2, 3. So subset means either it can have 1, 1, 2, or 1, 2, 3, right? So if A is subset of B, then PA is less than PB. It makes sense. Yeah, very nice. Then intersection, then we know all these rules here. So this union, consider a law and B event. So A union B union C, D formula, formula number D, A union B union C. So they are not mutually, they are non-mutually exclusive. They are non-mutually, they are overlapping events. Then formula will be PA plus P A dash means 1 minus A B intersection B plus P A dash plus in union P B dash union C. So like for now, I will ask you to remember this formula because we are not deriving it. So These are some simple properties of probability law. So A, B, C, if they are independent event and overlapping events, then the formula of A union B union C is this. AC means A dash. A dash A superscript C. A के ऊपर अगर C बना हो मतलब 1 minus A है वो. B के ऊपर C बना है मतलब वो 1 minus B है. Okay, so that's how this formula is. And for now, I'll ask you to remember it. And see now. Where? Yeah. So now there is one numerical example. Suppose two factories supplies light bulb. Only two factories are there who are supplying light bulbs to the market. Factory X bulb were over 5,000 hours, 99% means the condition is bulb should work more than 5,000 hours. So there is a 95% probability that factory X bulb will work more than 5,000 hours. There is only 95% probability that factory B bulb will work more than 5,000 hours. Means factory B's bulb are less reliable compared to factory A bulb. Okay. It is known that factory A supplies 60% of the bulb available, and factory factory X supplies 60% and factory Y supplies 40%. 60% of the bulb in the market belong to factory X and 40% belong to factory Y. What is the chance that purchase bulb will be together, will be the purchase bulb, a random bulb we are purchasing for the market, what is the chance that it will work longer than 5,000 hours? Market is having two type of bulb, X factory bulb and Y factory bulb. X factory reliability is 99% and Y factory reliability is 95%. 95. What we are measuring? Bulb should work for more than 5,000 hours. Okay, so now I'm from the market. I am buying one random bulb, and I don't know which. Maybe that bulb are not marked with factory X, factory Y. That branding is not there. I buy a random bulb from the market. So I'm asking, what is the probability that a purchase bulb will work more than 5,000 hours? More than 5,000 hours. Okay. So now you see, first of all, here it is again like PA dependent event like A. Okay, I'll take you this example again because I have to make up explanation for it. So I'll take this example later. Huh? I'll take this example later because right now,
Sure.
Yeah, tell me.
No, sure, sir. I mean, whenever.
Yeah, I'll take it later. So I'm not able to explain it right now, so we'll take it later. Okay, so now we are taking probability distribution next. Okay, probability distribution. So what is the probability distribution? Like probability distribution, how should I explain? Like here, you see, I'm having say large number of eggs, say maybe 1,000 eggs I'm having, and randomly here, and I'm measuring their weight. I'm measuring the weights of the egg. Okay, so now you see the left-hand diagram, which is kind of bar chart. So first bar represents some some eggs which are weighing very low. Okay, and very low means less than 1.6 ounce. Less than 1.6 ounce. They are very less. Then middle one eggs between 1.8 and 1.22 ounce. That is like middle one. It is highest quantity. Who are between 1.8 and 2, that is the highest quantity. So like that, when I go 2.2, which is overweight egg, that is also very less. Okay, so this curve now you see on the right hand side. Right hand side, how they have obtained this curve? Each bar is representing frequency. First bar you see very small bar, first bar. It is representing maybe 3, number 3. So 3 weight, 3 eggs, and then second bar. Second bar maybe it is explaining around 14. Third bar, how much third bar is representing? How much third bar is representing?
Approx 22.
22. How much fifth bar, middle one? So middle one is representing around
34, sir.
30, 32, 33, right? Like that, all bars are. What is this? Each bar is representing frequency. So means egg weighing between less than 1.6 are only 3, and eggs weighing more than 2.2, more than 2.2 1 or 2. Like that we can measure the frequency. Now how from this we have obtained the right hand side. How it has been obtained? You add up all the frequencies. So frequencies on the top, na? So you add up all the frequencies, 0 plus 5 plus 10 plus 15 plus 20 plus 25 plus 30 plus 35. Okay, so maybe all will add up to how much it will be? 30, 65, 65 plus 25. 65 plus 25, how much? 65 plus 25 will be 70, 90. No, they are more than 100 here. So total, whatever total is there, suppose
So
total is
140.
eggs. Huh?
140.
So total eggs we have measured is 140. Okay, around 140 eggs we measured. Now how this probability is calculated? So what is the probability of getting egg less than 1.6? So this bar you see, bar is around 3. So 3 divided by 140. 3 divided by 140. What is the probability of getting egg between 1.6 and 1.7? So that is second bar, right? So you add up around 14 divided by 140. Like that you have calculated. So now you have taken weights here on the you have taken weights on the x-axis and this probability on the y-axis. See, probability of getting less than 1.6. So there less than 1.6, how many eggs are there? Only 3. Total eggs are there 140. So I am marking 3 divided by 140, less than 1.6 ounce. Between 1.6 and 1.7, how many bars are there? 14 eggs. So that probability will be 14 by 140. Like that, I have calculated the probability and I have plotted on the right, on the y-axis. So that is my distribution. Understood, na? Is this understood?
Yes, sir.
Yes.
So that's how I have got the right-hand graph from the left-hand graph. So now, this is called probability distribution. Left-hand graph is called frequency distribution. And if I little bit modify it and calculate probability, so that is called probability distribution. So many natural phenomena. See, egg is a natural thing. I have taken 140 natural eggs. Natural eggs I have taken their weight. So see, it is an inverted bell curve. So it is called normal distribution. You might have heard about normal distribution. You might have learnt in your like some high school or something. If you don't remember, this inverted bell shape, it is like a bell, right? Mandir ki jo ghanti hoti hai. It is just like a bell. So this bell curve, whenever you get a bell curve in probability distribution, it is called perfect bell curve. When you get, it is called normal distribution. So we'll see what are the properties of these in one of our lectures. We'll see the probability of this. So left-hand side chart is called frequency distribution, and right-hand side chart is called probability distribution. And since it is a perfect bell curve, inverted bell curve, we call it normal distribution. Okay, or Gaussian distribution. So if you even you take instead of 140 eggs, even you take 140 people, 140 persons, random people. So suppose you have chosen like you went to some busy city vegetable market and you have taken random adults Adults I am telling you, not kids. Adults. Random adults you have taken. Total 140 males you have randomly chosen. Now what you have done, you have chosen their height. And then made a frequency graph like this. Height between 150 to 160 so many, 160 to 170 so many, 170 to 100 so many. Like that frequency chart you have plotted first and then converted into the probability distribution, which is like a right. Like then you calculated probability and then got your probability distribution. So that will perfectly follow normal distribution. So normal distribution is a very commonly occurring phenomena in, it's wonderful actually. Egg weight also normal distribution, and height of people randomly chosen, height of people also normal distribution. And if you see many other things, many other naturally occurring phenomena can be represented by normal distribution. It is wonder actually, statistical wonder. Like machine parts you are taking. So some round cylinder, suppose some round bolt are getting manufactured in a factory. Round bolts are cylindrical bolts are getting manufactured, and if you measure their size will not be equal. The size will not be equal. They will be always plus minus something. So maybe plus minus 0.01 millimeter. Their size will be, I suppose it is supposed to be 20 mm bolt. So size will be either 20 plus 0.01 or 20 minus 20.01. Like that height will be. And other bolts will vary in between 20.01 and 19.99. Like that it will vary. Lower will be 19.99, upper will be 20.01, and rest all bolts will vary between 19.99 and 20.01. If you plot them like this, that will also be a normal. So it's a wonder in normal distribution is a wonder in statistics of many natural occurring, a vast number of naturally occurring phenomena. They are following normal distribution. Okay. So now you got the idea of what is a probability distribution. Okay. Now here we have distribution of, now you got the idea of probability distribution. So these are 3-4 type of distributions given. Normal distribution is very common, which I said, which is Gaussian distribution. We'll study it in detail, and it is a used lot in Six Sigma, and Six Sigma techniques you might have heard like a lot in manufacturing, right? So they use to take the heavy use of normal distribution. Then right hand side is exponential distribution. See the shape. Then log normal. Log normal means the right hand side tail is little longer. That is log normal. And uniform distribution means from A to B, it varies uniformly. So these are some very common type of distributions, which we are going to study with formula in one of our future classes. We'll study many more. We'll study with the help of formula. Okay. So they are very commonly occurring probability distributions. I explained you what is the probability distribution. First, you plot a frequency distribution. From frequency distribution, you calculate probability, and then you plot a different graph. So it's a smooth curve. You get probability. So probability distribution may not be always a bell curve like this. It can be many. There can be many type of distribution. As I said, normal is perfectly bell curve. Then you are having exponential, log normal, uniform. There are many kind of probability distributions. So see, these are the only names I am giving you here. So like just have a look like how many type of probability distributions are there, and try to see their shape. So out of this, in one of our future lecture, we'll cover uniform distribution with formula, binomial distribution with formula, Poisson distribution with formula, exponential distribution with formula, student T. If you see on left hand extreme side, left hand side in the bottom, student T distribution, that will study with the formula. Normal distribution will study with the formula, and chi-squared will be chi-squared distribution, that also will study with the formula. Only things what we will not study. Now I am telling you which will not study is gamma, beta, well-bull, and geometric. So geometric, well-bull, gamma, and beta will not cover because they are very non-common kind of distributions. So only all the mainly which are used in statistics, everything will cover, very detailed, maybe 2 lectures on this. Okay. And we'll cover with formula. Okay. So we'll cover with formula. I'll tell you. So now, this I want to these are very commonly occurring distributions. So bell curve I told you. So bell curve is a inverted, perfect inverted, like perfect bell. So that is called normal distribution. So when we use it, so many naturally occurring phenomena, they follow bell distribution. So like height, weight, IQ of a person. If you take 200 people at random and calculate their IQ, give them IQ test and find out their IQ, that will also follow normal distribution. Then test score, like many students, suppose there are 62 students in the class, you give them test paper and calculate their scores. Their scores will also follow normal distribution. It's a wonder actually. Then normal distribution, you should have sample size more than 30. Normal distribution, your sample space should be more than 30. If sample space is less than 30, then we go for a T distribution. It is also a bell curve, but sample size is less than 30. Formulas are different for that. Okay. So when sample size is small, we don't have many sample points, then we'll go for T distribution. And so that is how both are same actually. Normal distribution and T distribution almost same. When in T distribution, when sample size goes beyond 30, it follows normal distribution. Then binomial distribution. So binomial distribution means if there are some cases like only 2 possibilities are there, success and failure, like tossing a coin. So tossing a coin means head means success and tail means failure, right? So if only 2 kind of possibilities are there, 0 and 1, like that, then we use binomial distribution. Coin toss, head tail. So in such a case, to predict coin toss, we will use binomial distribution. Okay. So suppose you have a result like binary yes or no. Suppose outcome only two outcomes should be there, not more than 2. One is yes, one is no. Either sample space should be only 2. Either yes, no, black, white, vote, don't vote, BJP, Congress, only 2 should be there. That's all. Not more than 2. Then we'll use binomial. Poisson means I'll give you a distribution like Poisson is a little complicated kind of distribution where like I give you example like if I say I'm an airport manager, okay, say Bangalore airport manager, and you go to the Bangalore airport and tell him that I'm a statistician, like I'm trained in statistics. Then he will tell you a simple question, like he may ask you a simple question. I have counted so many days, average flight that come every hour. Average flight that land every hour. Land means landing. Land every hour in Bangalore airport are 20. Average flights that land in Bangalore airport are 20. Means there are 20 events. What event is? One event is landing one aircraft is one event. So suppose there are only 20 events like that. Now my next question is, tell me the probability that in any hour during the day I will see 30 landings instead of 20. Average is 20. But tell me during any hour in the day, what is the probability that I will get 30 landings? He's asking you what? I want any particular hour, like my landing should be 30. Why he wants like figure like that? 20 landing, the resource deployment will be different. 30 landings, report deployment will be different, right? So average is 20 landings per hour. Now he's asking you that for a particular hour, what is the probability that 30 landings will be there? So for such kind of problems where we count events, and event should have some interval, right? So 20 landings in an hour means every 3 minutes one landing is happening, right? So the event should have some space in between them. Such kind of problems we use Poisson distribution. And exponential distribution means service industry we use it, like a light bulb is there. So when light bulb becomes on, it is giving a service. When light bulb is on, or a tube light, when it is on, it is giving a service. What service it is giving? It is giving you light. Now I will tell you that this problem, this kind of problem, na? This kind of problem, this kind of problem. Bulb and all. When we want to find the calculate of the life of the bulb, service, in case of service, when we are not having events, we are having service. That case will apply exponential distribution. Means I will ask you that average life of a bulb is 4,000 hours. Average life of a bulb is 4,000 hours from a particular factory. What is the probability that this bulb will go beyond 4,000 hours? So that kind of calculations will use exponential distribution. So this is exponential distribution means in case of service, there is no event in this. So service, it should be service. Okay. So like that we use. Generally, I have given you an idea. Then this is a complete kind of encyclopedia of kind of how to make a choice of the distribution. So we are not going into detail of his, but if you, in case you want to go detail after once we advance in our course and you understand distribution, you can use this to make the choice of so many are there, right? See, so many kind of distributions are there. So which one to choose when? So this is the table actually. So right now we are not going through this. I have given it for the sake of completeness. So once you have developed more understanding about distribution, then you can use this to make a choice when you are confused, right?